an opening of 1500 mm. Bearing on either side of the wall is 230 mm. Width of the wall and lintel is 230 mm. Overall depth of the lintel is 200 mm. Lintel is provided with 4 bars of 12 mm diameter as main reinforcement, out of which 2 bars are cranked at a distance of 0.15 times the clear span from each support, and 2 bars of 10 mm diameter as anchor bars. 2-legged 8 mm dia stirrups at 180 mm center to center are provided as a shear reinforcement. The sunshade is projected at a distance of 600 mm with a thickness of 100 mm at fixed end and 60 mm at free end. The main bars used for sunshade are 10 mm dia at 140 mm center to center, and distribution bars are of 8 mm diameter at 140 mm center to center. Assume all the covers are 25 mm. M20 grade concrete and Fe 415 steel is used for the construction of lintel cum sunshade. Draw the following to a suitable scale. Number 1. Longitudinal section of lintel. Number 2. Cross section of lintel cum sunshade. Next one. Prepare schedule of reinforcement and bar bending schedule of lintel cum sunshade. Let's draw the longitudinal section of lintel. The clear span is 1500 mm. Bearing on two sides is 230 mm. See, this is the main bar, this is the cranked bar. This one is top cover and this one is bottom cover. These two are end covers. And see, these are the vertical stirrups. We have to calculate the number of stirrups used for this lintel. The stirrups are 8 mm dia at 180 mm center to center. The main bar and cranked bars are given as 4 numbers of 12 mm dia, out of which 2 are main bars. These 2 are cranked bars, 2 numbers, 12 mm dia. Similarly, main straight bars are 2 numbers, 12 mm dia. This is a hanger bar. It is also known as anchor bars. 2 numbers of 10 mm diameter, and this cranking portion is at a distance of 0.15 times this span. Say it is L. Similarly, in this side also 0.15 times clear span. Now calculate the lengths of main straight bar, main cranked bar, hanger bar and stirrups. The schedule of reinforcement. Say first one is main straight bar. So it is designated as A. Length of main straight bar is equal to LMS is equal to this length 1500 plus 230 plus 230 minus this cover minus this cover. Clear span 1500 plus 2 times bearing 230 minus 2 times end cover, which is equal to 1910 mm. Number of main straight bars are already given in the question. 2 numbers. Next one is B, main cranked bar. Length of main cranked bar, say LMC, is equal to length of main straight bar plus 2 times the crank allowance. Length of main straight bar plus 2 into crank allowance. See, this is the crank bar. Overall depth of the lintel is 200 mm. One crank allowance is equal to 0.414 times D. So this D is equal to 200 minus top cover minus bottom cover minus half of this dia minus half of this dia. Therefore, length of main crank bar is equal to 1910 plus 2 into 0.414 into 200 minus 25 minus 25 minus dia of cranked bar is 12. So half of dia 12 by 2 on this side and half of dia here 12 by 2. Length of main crank bar is equal to 2013.60 mm. mm. C, hanger bar or anchor bar. Length of hanger bar is equal to length of main straight bar. See, this is the longitudinal section, this is the main bar, and this is the cranked bar. We provide the hanger bar like this. So this length is equal to length of straight bar. So length of main straight bar. LH is equal to 1910 mm. Number of hanger bars is equal to NH is equal to 2, given in the question. Next one is stirrups. we provide vertical stirrups along the lintel. Length of vertical stirrups LST is equal to, say this is the cross section of a beam. The stirrup is laid like this. These two are the 135 degrees bends. Say it is B, overall depth D. We have to calculate the center to center dimension of stirrups in this direction as well as in this direction. So total length of vertical stirrups is, say this is BS and this is BS, 2 times BS plus DS. 2 into BS is 200 and overall depth is 300. And all the covers are 25 mm. Therefore, BS is equal to 200 minus covers on both sides, 2 into 25 plus half of dia here plus half of dia, 2 into diameter of stirrups by 2. Plus overall depth is 300 minus 2 into cover on the top and bottom. So here you can write directly 2 into cover. Why? Because the cover is same for top portion and bottom portion. 2 into 25 plus half of dia here, half of dia here, 2 into 8 by 2. Length of stirrups is 1024 mm. Number of stirrups is equal to total length of lintel excluding end cover divided by center to center spacing of stirrups plus 1. This is the longitudinal section of lintel. We provide the stirrups like this. We know the spacing and diameter. Here we have to find the number of stirrups in the longitudinal direction of lintel. So this is the total length of lintel excluding the covers divided by spacing. Total length is equal to clear span plus 2 into bearings minus end cover on both sides divided by end cover on both sides into 2. Center to center spacing is 180 mm plus 1. Therefore, number of stirrups is equal to 11.612. Say it is 12. Now calculate the length of different bars used in the sunshade. Let's prepare this schedule of reinforcement for sunshade. The first one is main straight bar in the sunshade. Let is MS in sunshade. This is the cross section of a lintel. See, these two are the hanger bars. Two numbers, 10 mm dia. This is the vertical stirrups, 8 mm dia. At 180 center to center. These two are the main cranked bars. Two numbers, 12 dia. These two are main straight bars. Two numbers, 12 dia. These are the vertical stirrups. Here, this is the main straight bar in the sunshade. The diameter is 10 mm at 140 center to center. These are the distribution bars in the sunshade. This is the main bar. These are the distribution bars. Eight mm dia at 140 center to center. See, this main bar is provided on top side. Why? Because it's just like a cantilever beam. This, when you bending moment is taken place, it bends like this. So this layer is having tension and this portion is having compression. So the main reinforcement is provided on the top side to resist the tension. Now find the length of main straight bar in the sunshade. LMSS is equal to, this is the width of lintel, this is the projection of sunshade given as 600 mm. So 300 plus 600 lintel width plus sunshade projection minus this cover and this cover minus 2 into 25 plus this bending allowance. Say it is, assume it as 90 mm. Total length comes to 940 mm. Next, distribution bar. In sunshade, length of distribution bar is equal to length of lintel excluding end covers. Therefore LD is equal to 1500 plus 2 into 230 minus 2 into 25, which is equal to 1910 mm. And find number of distribution bars. Is equal to, this is the cross section of lintel cum sunshade. This is the main bar and these are the distribution bars. So this may be 8 mm, 140 center to center. The numbers are calculated based on this projection. This is 600 mm. So 600 minus, so this bar is extended to here. So we have to deduct only one cover on this side, minus cover 25 divided by spacing. Spacing is given as 140 center to center plus 1. Therefore number of distribution bars is equal to 5. 5 numbers. Number of straight bars in sunshade is equal to total length of lintel excluding end cover divided by center to center spacing of main straight bar plus 1. The number of main straight bars in sunshade is equal to 1500 plus 2 into 230 minus 2 into 25 divided by spacing is 140 plus 1, which is equal to 15 numbers. We get 14.6 rounded to 50 numbers. Now prepare the bar bending schedule. First one is A bar. This is main straight bar in the lintel. Bar shape is straight. Diameter of bar is 12 mm. Number of bars are 2. Length is 1.910 meters. Total length is equal to number of bars into length of bar, which is equal to 3.820. Weight of the bar is equal to diameter square divided by 162.2. Diameter is 12. 12 square by 162.2 is equal to 0.887. Total weight of bar is equal to total length of the bar into weight of the bar. Meter into kg per meter. Therefore total weight comes in kgs. 3.388. Second bar is B. This is main cranked bar in lintel. mm dia, 2 numbers, 2.014 meter length. Total length is equal to 2 into 2.014, 4.028 meters. Weight of the bar is equal to 12 square by 162.2, 0.887. Total weight is equal to 7th column value into 8th column value, 3.572. Third one is C bar, which is anchor bar in the lintel. 10 mm dia, 2 numbers, 1.910 meters length. Total length is equal 3.820. Weight of the bar is equal 10 square by 162.2, 0.616. Total weight is equal to 3.820 into 0.616, 2.353 meters. Next bar is capital D, stirrups, vertical stirrups. In the calculation, add this 135 degrees bends. Here, length of one bend is equal to 12 times diameter of stirrup. We have 2 bends, so 2 into 12 times diameter of stirrup, 8 mm. Total length of stirrups is 1024 mm. Diameter of stirrup is 8 mm. Number of bars are 12. Length of one vertical stirrup is 1.024. For 12 number of bars, total length is equal to 12.288 meters. Weight of the bar is equal to 8 square by 162.2, 0.394. Total weight of the bar is equal to 4.841. These 4 bars are used for lintel. Now next 2 bars are used for sunshade. See, E is the designation used for main straight bar in the lintel. It is having a shape like this. Diameter of main straight bar in the sunshade is 10 mm. Number of bars are 15. Length of the main straight bar is equal to 0.940. Total length is equal to 15 into 0.940, 14.100. Weight of the bar is equal to 10 square by 162.2, 0.616. Total weight is equal to 8.685 kgs. Last bar is distribution bar in the sunshade. It is a straight bar, 8 mm dia, 5 number of bars are used, 1.91 meter length. Total length is equal to 9.550. Weight of the bar is equal to 0.394. Total weight is equal to 3.762. Now total quantity or weight of the steel required for lintel and sunshade is total quantity of steel required is equal to 3.388 plus 3.572 plus 2.353 plus 4.841 plus 8.685 plus 3.762, 26.601 kgs.